Dear students, in the previous class we have seen the different types of sets of number sets and the representation of the sets. So in the previous class we learned about the different types of sets. So come on, tell me some of the sets. Yes, it is first one is n, that is for natural numbers. Next, yes, it is w for whole number. Next, z for integers. What is the next set? Yes, it is q for rational numbers. Next, I or irrational numbers, and the mother set or the universal set. Which is the mother set or universal set of all these sets? Yes, it is real number set. So we have seen this type of sets, and also we have learned to write the rational numbers between any two numbers. How to write? In the previous class we know how to write the rational numbers between any two rational numbers or any two numbers. So students, today we shall see how to represent the irrational numbers on the number line. Today we shall study how to represent the irrational numbers on the number line, and also we will study today the decimal expansion of the real numbers. Decimal expansion of the real numbers. Students, all of you know that there are set of irrational numbers. Irrational numbers means, you know that a set of irrational numbers, it contains the numbers which cannot be expressed in the form of p by 2. Which cannot be expressed in the form of p by 2. So can you tell me the examples? Yes? Yes, root 2. Root 2. Next. Yes, it is pi. Next, root 3, root 5, etc. So these type of numbers are called as irrational numbers. So because we cannot express them in the form of p by 2. So in this class we will see the representation of these irrational numbers, root 2, root 3, root 5, etc. on the number line. Students, for this representation of the irrational numbers on the number line, we are going to use the most famous theorem, that is Pythagoras Theorem. Pythagoras Theorem, which is given by the Greek mathematician Pythagoras. So students, now we shall see representation of irrational numbers Students, all of you familiar with the number line already. That means you have already studied the number line in the 6th and 7th standard. 6th and 7th standard. So to represent the irrational numbers, we use Pythagoras theorem. Pythagoras theorem. Before going to represent irrational numbers on the number line, now we shall see what is the statement of the Pythagoras theorem, which is given by the Greek mathematician Pythagoras. So this Pythagoras theorem is related to the right angle triangle. It is related to the right angle triangle. So now observe here, we know that right angle triangle means if in a triangle, if any one of the angle is equal to 90 degree, it is called as a right angle triangle. In a triangle, if any one of the angle is equal to 90 degree, it is called as right angle triangle. So here in the figure, ABC is a right angle triangle. ABC is a right angle triangle in which angle B equal to 90 degree. Angle B is equal to 90 degree. Now, if you recall the properties of the right angle triangle, that means in a right angle triangle, the side which is opposite to the right angle, is called as hypotenuse. We call it as AC. AC is called as hypotenuse because it is opposite to the right angle. Okay. So, and again, if we see the property of the right angle triangle, in a right angle triangle, hypotenuse is the longest side or larger side of the right angle triangle. So for this right angle triangle, he given the statement and prove the theorem. So that is called as Pythagoras theorem. So in this class, we will see the statement only. So you will study this Pythagoras theorem and its proof in detail in the 10th standard. Okay, students. So it states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other sides. Other two sides. This is the statement of the right angle triangle. Students, so this is an important statement you have to remember. So it will help you in the next standard, 10th standard also. So in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. So you will do this theorem in the 10th standard. Okay. Students, let us see an example to understand this statement. So here I have taken BC as a 3 units, so AB as a 4 units, and AC as a 5 units. 5 units. Maybe the units means the length may be in the centimeter or it may be in the meter. So AB is 4 units, BC is 3 units, and AC is 5 units. So apply this statement to the given right angle triangle. So in a right angle triangle, square on the hypotenuse, which is the hypotenuse here? Yes, AC is the hypotenuse. So if you square that hypotenuse, it means AC square equals AC square equals the square on the hypotenuse is equal to the sum of the squares of the other two sides. The other two sides are AB and BC. We have to square these two and add those two sides. AC square equals AB square plus BC square. So the length of the AC is 5 square equals the length of AB is 4 square, the length of BC is 3 square. So if you simplify, 5 square means 5 should be multiplied twice. 5 into 5, it is 25 equals 4 4s are 16 plus 3 3s are 9. So 25 equals 16 plus 9, it is 25. So therefore LHS equals RHS. So this knowledge is enough to understand that the statement of the Pythagoras theorem in the 9th standard, students. So I think you have cleared about the statement of the Pythagoras theorem. Okay. Now we shall see. So this is important to represent, to know for the representation of the number line of the irrational numbers. Students, now we shall see the problem. Locate root 2 on the number line. So the problem, locate root 2 on the number line. So, or it can be asked as represent root 2 on a number line. Both are same. So students, now we shall see the step-by-step method to represent the root 2 or an irrational number on the number line. So for this, students, we are going to use a right angle triangle which is already known. So take a right angle with equal units. So this is a right angle triangle want. Okay. So AOB is a right angled triangle. The length of OB is 1 unit and the length of OA is also 1 unit. Because we want to represent root 2 on the number line, so we have to take OB as a 1 unit and OA as a 1 unit. By the statement of Pythagoras theorem, by Pythagoras theorem, by Pythagoras theorem. Come on, tell me the statement of the Pythagoras theorem. Yes, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. So if you apply this, so here which is the hypotenuse here? Yes, AB is the hypotenuse. Why AB is hypotenuse? Because it is opposite to the right angle. If you apply that, AB square equals OB square plus OA square. So now substitute the value. OB is 1 square plus OA is also 1 square. You simplify it. 1 ones are 1 plus here also 1 ones are 1. Which will be equals 1 plus 1 2. AB square equals to the value of AB. If you remove the square, it will be root for the right side. AB equals root 2. AB equals root 2. Now students, so we have got the irrational number root 2. Now we will represent this root 2 in the number line. For this, we have to draw in the step 1. First step. Step 1. We have to draw the number line. Number line with equal units. Students, now the first step is we have to draw the number line. We have to draw the number line with equal units. Equal units. All of you are already familiar with this number line. So on the number line, the numbers which are right side is 0 are positive numbers. They are positive numbers or positive integers. The numbers which are left side of the 0 are negative integers. In the first step, you have to draw a number line with suitable units. So here I have taken the number line 0, 1, 2, 3 to the right side, -1, -2, -3 to the left side. In the second step, students, we have to draw a right angle triangle in the on the number line. Shall we take the measurements? Already in the problem we have taken the length of OB is 1 unit and the length of OA is 1 unit. OB is 1 unit and OA is 1 unit. So now here we have to draw a right angle from O, right angle triangle from O. So this will become 0 for the number and O for the alphabets. So I have taken 1 minute and call this as A, this point as A, this point as O. At A, construct 90-degree angle with the help of the protractor. At A, construct angle 90 degree with the help of the protractor. Observe clearly, students. So here I have constructed 90 degree. So what is the measurement of side OA? It is also 1 unit. So with the help of the divider, take 1 unit measurement and so mark a point on this side and call it as B. Call it as B. So now join OB. Now join OB. Join OB. We will get a right angled triangle OAB. OAB. So in this figure also we can change the name. So it will becomes OAB. Then here it is OB square. OB square equals OA square. OA square plus AB square. AB square. Therefore, OB square equals 2. OB equals 2. So I have say construct. I have made a small change here. That means I have changed the alphabets for the diagram because we have already 0 in the center of the number line. Therefore, it will be taken as O. So, for in the second step, we have constructed the right angle triangle on the number line. So, in the third step, so if we take, we should take the next step, we should take the length OB with the length OB. The length OB. So here the units of it is OA is 1 unit, AB is also 1 unit. So in the third step, we are going to draw an arc. Draw an arc. Or semicircle with O as a center. With O as a center. Now we will do it this third step. In the third step, just we are going to with OB as a measurement. Here once again I am constructing the right angle triangle, because to know the clear way to represent the number line, or this as A, B, so this will be 1 unit, or this will also 1 unit, this will also 1 unit. So the same rectangle triangle is constructed there. So with OB as a length, or OB as a measurement, O as a center, draw semicircle. Draw semicircle. If you draw the semicircle, this semicircle intersects the number line in two different points. Call them as M and N. Call them as M and N. So these points on the number line M and N represents the value of root 2 on the number line, where N is the positive value and M is the negative value of the root 2. Again, N is the positive value, M is the negative value of the root 2. Or you can take only positive value. Yes, that means N itself represents the positive value of the root 2. Therefore, we can conclude that on the number line, on the number line, the points M and N represents the value of root 2. Value of root 2. So, okay, I think you have understand how to represent the root 2 on the number line. So, I will repeat once again. In the step 1, you have to draw the number line with equal units. In the step 2, you have to construct a right angled triangle with OA as 1 unit and AB as 1 unit on the given number line. After that, so we have to take with a measurement of OB, with O as a center. Measurement of OB, or the length of OB with O as a center, the semicircle. So this semicircle intersects the number line in two different points M and N. So where the M and N represents the value of root 2. M represents the negative value of root 2 and N represents the positive value of the root 2. Okay, students? Students, now observe if you find out the value of root 2, it will become plus or minus 1.4142. It will goes on continuously. So, in the, for your reference in this ninth standard, so it will only the positive values. So you have to study only the positive values. Therefore, this the value of root 2 is taken as 1.4 approximately equal to 1.4142 approximately equal to, so 1.4142. So that means you have I have uh, explained you how to represent both the positive and negative value of the root 2. In this chapter, we have only positive value of the irrational numbers. Therefore, you can delete this part. So this part means left side, or you can practice both. So it will help to know the negative and positive value, because this will be the same value to the left side and it will be same for the right side. Therefore, I have showed you how to find out the value of root 2, both positive and negative. You can take only positive, so that means to the right side it will become approximately equal to 1.414. Okay, students, now we shall see another one to locate the number line. Students, now we shall see another problem. Locate root 3 on the number line. Locate root 3 on the number line. For this, see, as in the previous problem, we have to take a right angle triangle. So already we know how to represent the root 2 on a number line. For that, we have taken a triangle OAB. We have taken a triangle OAB. So by taking OA as 1 unit and AB as a 1 unit, so then if the value of OB will be root 2. So after that, we have to draw a right angle on the line on the side OB. On the side OB, we have to draw a right angle with 1 unit. So with 1 unit, the value of OA is root 2 and the value of BC is 1 unit. So then the value of OC represents root 3. Now we shall see by applying the Pythagoras theorem for this diagram. So here in triangle OBC angle B equals 90 degree. So by Pythagoras theorem, the side which is opposite to the right angle, that means OC square equals OB square plus BC square. So now substitute the value. OB is root 2 whole square plus BC is 1 unit 1 square. It will become 2 and root 2 can the value of root 2 is half and 2 get cancelled, so we will get 2 plus 1. So OC square equals 3, or if you take square outside left side the square, you will get the right side. So OC is equal to root 3. So just write down the values by applying Pythagoras theorem. So we are going to apply for this triangle BC. So hypotenuse is OC. OC square equals to OB square plus BC square. So the value of OB square is root 2 plus the value of BC is 1. So root 2 whole square plus 1 square, root and square or get cancels. So you have already studied this in the 8th standard. How to cancel this? It will become 2 plus 1 ones are 1, or 2 plus 1 is 3. OC square equals 3. We remove the square, we will get the root on the right side. The value of OC is root 3. Now, in a similar way, that is in the previous problem. So, draw in first step. Draw the number line with equal units. Step 1 is draw the number line with equal units. I have already drawn it. So, in the next step, second step, once again on the number line, construct a right angled triangle. Construct a right angled triangle with 1 unit. So next we have to extend this on with the point B. With the point B again we have to construct 90-degree angle, 90-degree. So I am constructing the angle 90-degree. So it will be the right angle now. It will be the right angle 90-degree. And cut that with measurement 1 unit. With the measurement 1 unit. 1 unit. With B as center. Draw an R. We will get point C. We will get the point C. Now join OC. Now join OC. This represent root 2. This is 1 unit. So now we have a triangle OBC. So similarly, in the third step or the next step is very simple. I will show here it only. So now we have to take the length equal to OC. Length equal to OC. Draw an R. Draw an R to the right side. Draw only to the right side because you have to represent only positive value. So here the point on the number line, you can name any alphabet called as P. So on the number line, P represents the value of root 3. P represents the value of root 3. Friends, similarly you have to represent the other problems on the number line. That is root 5, root 7, etc. So this is a model for these two are the model for you to represent the or to locate the irrational number in the number line. Yes, students. Students, now we shall see the real numbers and their decimal expansions. Some of the real numbers and their decimal expansion. So, example, find the decimal expansion of 7 by 8, 1 by 2, 329 by 100. You are already familiar how to convert the fractions to the decimal in the 6th, 7th in the previous standards. First one, we have to convert this 7 by 8 to the decimal form. So divide 7 by 8. So if you divide, it will become 8. If you divide, it becomes, we will get the value 0.875. That means we have to put the point here. We will get the 0. 8 8s are 64. The remainder is 6. So we have already taken the point. 0 will come here. It will become 60. 8 7s are 56. The remainder is 4. It will become 40. So then 8 5s are 40. The remainder, lastly, the remainder will be 0. So this is you have already have done in the previous standards. So therefore, the value of 7 by 8 is 0.875. Similarly, if we find out the value of 1 by 2, or if we convert this to the decimal form, and this is an example, so simplified form, it will become 0.5. Here also, the remainder will be 0. That means the dividing process will be ends with the remainder 0. Similarly, in the third example, 320, the value of 329 by 100. If you go on dividing, you will get the value 3.29. Here also the remainder is 0. That means the division process ends. So if you observe from these examples, the value of 7 by 2, 7 by 8, value of 1 by 2, value of 329 by 100. So in these examples, the division process ends with the remainder 0. So the decimal expansions, what we get 3.29, 0.5, 0.875, they will end after some steps. After a finite number of steps, such decimal expansions are called as terminating decimal expansions. So the division ends with the remainder 0. That means it will end after a finite number of steps. So such decimal expansions are called as terminating decimal expansions. Terminating decimal expansions means the division process will be ends by remaining the remainder 0. You have to know this clearly, or you can remember this for the further problems. Okay, students. Now we shall see another set of decimal expansion of the rational numbers or real numbers. So because rational numbers are present in the set of real numbers. Students, now observe the another set of decimal expansion of the numbers. Here is find the decimal expansion of 1 by 3 and 1 by 7. So if you simplify this 1 by 3, you will get 3 3s are 9. Again 1 is the remainder. So 3 3s are 9. 1 is the remainder. 3 3s are 9. 1 is the remainder. So therefore the value of 1 by 3 is 0.33. So that means the remainder will not becomes 0 here. The remainder will not becomes 0 here. So therefore the decimal expansion is repeating. So it is repeating. 3 is repeating. So but the remainder does not end to 0. Therefore, this can be written as 1 by 3 is equal to 0.t bar. If you draw a line bar on the line on the number, it indicates that that number will be repeating continuously. So until the it will not have the end. So 1 by 3 is equal to 0.3333. So if we take the another example 1 by 7, so if you go on dividing this or simplifying 7, if we take the point as it will become 10, 7 ones are 7, the remainder 30 will becomes, so 7 4s are 28, 2 is the remainder, it will becomes 20, 7 2s are 14, and if you subtract this, we will get a 6 and it will become 60. 7 8s are 56, subtract, you will get the remainder 4, and 40 will become 40, so 7 5s are 55, so 5 is the remainder, so it will become 50, 7 7s are 49, remainder is 1. So here also if you observe the process, here also the remainder will not become 0. So after this, the same process will be repeated. That means the same numbers will be repeated. So therefore, the value of 1 by 7 equals 0.142857142. So again, it will repeat. The same numbers will be repeats after a period of the division. So therefore, it will repeat after the decimal point is 7. So therefore, we can write this as 1 by 7 equals 0.142857 bar. That means after the ending of the 7, the same digits will be repeated. So this type of decimal expansions, they will not have the end. The division process will not end. Such decimals are called as non-terminating. So terminating means the division process ends with leaving a remainder 0. So non-terminating means it is recurring. That means the decimals will be repeated. Decimal points will be repeated. But here the remainder is will not become 0. So it is called as non-terminating recurring decimal expansion. Students, I think you have cleared about the terminating and non-terminating decimal expansion. So from this example, you have to simplify the exercise problem, exercise 1.3 first main. So in the exercise 1.3 first main, So there is a problem is that write the following in decimal form. You have to first what I have done in the blackboard. So you have to first simplify that. So you have to convert that to the decimal form. Write the following in the decimal form and say what kind of decimal expansion each have. So after the completion of the division process, observe the values of quotient and you have to write so which type of decimal expansions they are. Whether they are the terminating or non-terminating recurring decimals. Okay students, shall see in the next class.